Okay, problem 10. A, find the distance from a point S. Okay, so we know a point S. It is 3, -1, 4. To the line L. Okay, this is the line L. So this Lx is 4 minus t. Y is 3 plus 2t. And z is -5 plus 3t. Okay, t is a real number. Okay. So find the distance. Okay, to find the distance, you always need to find a random point on L first. Okay, so let's find a random point. Let's call it P. So how to get a random point on L? The simplest way is just let T to be 0, right? If you let T to be 0, then you can easily get a point 4, 3, -5. Okay, 4, 3, -5. Okay, then you can construct this triangle. Okay, then you can construct this right triangle. Then this is the distance, right? This is the distance you want to know. Okay, and let's say you treat this SP as a vector. Okay, so this is vector SP. So the distance is vector SP's length, right? Times, okay, let's treat this as theta times sine theta, right? Okay, now SP you already know, right? SP you already know. So the length of SP is not a problem. So SP is just point P minus point F. Okay, it's point P minus point F. It's 1, 4, -9. Okay, it's 1, 4, -9. So the problem is, what is this theta? Right? You have no idea what this theta is. Okay, so it seems like it's correct. It's a correct but useless formula. All right. So here's a trick. Here's a very smart trick. We can multiply this whole thing by 1, right? We can multiply this guy by 1, okay? Because everything can multiply itself by 1, and it doesn't change the result, okay? But instead of write it as 1, we write it as, okay, now first let's call the direction of this line V, okay? Then how do you get V? V is simply the coefficient of t. Okay, V is simply the coefficient of t. So V is just -1, 2, 3. Okay. So back to the equation. Instead of writing it as times 1, write it as times the length of the unit vector of V. Okay. First, why can we do this? Right? Why can we do this? Because the length of a unit vector is always 1. Okay, so it doesn't affect this value. Okay, it still will be the same thing. Okay, it still will be the same thing. Okay, let me write one more, an extra step. Okay, times the length of V hat. Right, then this should remind you of something, right? Because just now when we discussed the length of U cross V, it's the length of U times length of V times sine theta. So the length of SP and V, sorry, length of SP times length of V times sine theta, right? It is exactly the length of SP cross V hat. It's the length of SP cross V hat. Okay. So then this is a formula for the this is a formula for the distance from a point to a line. Okay. Of course, you can just apply this formula. There's nothing wrong. Here is just a two-step derivation of this formula. Okay. Then we just need to finish our calculation. So SP is what? Is 1, 4, -9. Okay. Cross v hat, right? V hat is 1 over square root of 1 plus square root of 2 plus square root of 3, which is square root of 14, right, times negative 1, 2, 3. Okay, and here the cross product. All right. First, these constants, we can move it outside. Okay, it doesn't matter. It's 1 over square root of 14. And then the cross product, right? Just follow the formula. It's a determinant of this. The second component is a determinant of this. And the last component is a determinant of this. Okay, last component is a determinant of this. Right, so it's 1 over square root of 14. Okay, so it's 12 minus 18, it's 30. And here it's 3 minus 9, it's negative 6, so it's positive 6. And then here it's 2 minus negative 4, so it's 6. Okay, so it's square root of 1 over square root of 14 times the square root of 30 square plus 6 square plus 6 square. Okay, so the answer is 9 square root of 42 over 7. Okay, 9 square root of 42 over 7. Okay, part B. Part B, very, very similar, but here is the distance from a point S to a plane. Okay, now instead of a line, we have a plane. Okay, instead of a line, we have a plane. So the plane is x plus 2y plus 2z is equal to 13. Okay. Again, we have to find a random point. Okay. Now to find a random point, I can just let yz to be 0, right? So my x is 13. This is not the only choice. You can choose other points as well. But let's just say if we pick P, right, 13, 0, 0 as our point on the plane. Okay, now we can draw the triangle. Right, now we can draw the triangle. But again, we have this vector SP, right? We already know what's the vector SP. So it's 13, 0, 0 minus 2, negative 3, 4. So it's 11, 3, negative 4. Okay, it's 11, 3, negative 4. And this is a distance we want to know. Okay. But here, so if we follow part A, we treat this as our theta. Okay, we do the same thing. Then you realize we need to know this vector. Okay, we need to know this vector lying on the plane. However, we have no idea what this vector is, right? We have no idea. We know this point, but we don't know this point. Okay, so that's a problem. You can try it. You can try this theta, but you will get stuck. Okay, but there are two acute angles, right? You can always try the other. You can let the other to be theta. Again, why? Because it's a plane. So you already know the normal vector to the plane. Okay, that normal vector is just the coefficients of x, y, and z. It's just 1, 2, 2. Okay, so here we can do this very similar thing. So first, the distance is a length of SP. Okay, now because we call this angle theta, right? So it's the length of SP times cosine theta. Okay, and again, we have no idea what theta is, so we can't continue. But we can apply the same trick. It's the length of SP times cosine theta times, right? Let's call this vector normal vector times the length of the unit vector of the normal vector. Okay, because this length is 1. You can always safely multiply anything by 1. It won't change its value. Okay, but by writing it this way, you can suddenly realize that it follows the formula of the dot product, right? U dot v is length of u times length of v times cosine theta. So here it's the dot product of SP and hat. Okay. However, here's just a sketch. Okay, we don't know exactly what's the direction of n, what's the direction of SP. So it's likely that this result could be a negative number. Okay, it could be the negative distance. So what we need to do is actually put an absolute value symbol from the beginning to make sure this distance is a positive number. Okay, so now we can continue. So SP is 11, 3, negative 4. Okay, dot product n is given. So n hat, the unit vector is 1 over square root of 1, square root of 2, square root of 2. So it's square root of 9, it's 3. So dot product 1 over 3, 1, 2, 2. Okay, and we put an absolute value. Okay, then it is 1 over 3, okay, 11 times 1 plus 3 times 2 plus negative 4 times 2. Okay. And the result is 3. Right? The result is 3. Okay. So of course you can skip these 2 steps, right? You can skip these 2 steps and just jump to this formula. It's also fine. Okay. It's also fine. And part C. Part C is the distance between 2 parallel planes. It's distance between 2 parallel planes. So you're given, right, this plane is x plus 2y plus 6z is 10. And here it's x plus 2y plus 6z is 1. Okay. All right, so how do you get the distance between these 2 planes? How do you get the distance between these 2 planes? So it's actually very, very simple, very, very similar to part B, right? You can pick a random point on plane A. So let's just, let's just treat yz to be 0. So this point on the top plane, let's call it Q, right? It's just 10, 0, 0. And let's pick another random point on the bottom plane. Again, we can let this to be 0, so we have another plane P. Okay, it's 1, 0, 0. Okay. Then, right, it's changed to part B. Right, then it's changed to part B. So if you want to derive the formula again, you can do it by yourself. But it's the same as part B, right? You can treat this as theta, you can get the normal vector. So the distance, let's just copy it from part B, is the vector PQ dot product, the unit vector of the normal vector. So here, what's a normal vector? What's a vector that is perpendicular to both? It is 1, 2, 6. Okay. So what is PQ? PQ is just Q minus P. So it's 900 dot product. Okay, 1 over. Okay, here's 1 square plus 2 square plus 6 square. It is 41, square root of 41, 126. Okay, and you put an absolute value. So you do the calculation, it's 9 over square root of 41. Okay.